Welcome to U5L3, Finding Angles Using Trig. So we talked about in the last lesson how trigonometry has many uses. One such use, which we talked about in lesson 2, was finding missing sides in right triangles. And so now what I want to talk about is what if we're actually missing the angle measure itself, right? What if that's what we need as an angle measure in a right triangle? How can we find it? Well, in order to find angle measures, we have to use basically inverse of trig ratios, okay? We have to use their inverse functions. So, for example, for sine, the inverse of sine, we also call arcsine. The inverse of cosine, we call arccosine. And the inverse of tangent, we call arctangent. And what that inverse function does is it allows us to say, okay, I know what the ratio itself is equal to. I either have the fraction or the decimal form, right? Tell me what the angle is, right? Tell me what angle would give me that ratio, okay? And so that's what that allows us to do. Your calculator still needs to be in degrees in order to do this properly, so keep that in mind, okay? All right, so for example, one, use a calculator to find the measure of each angle to the nearest degree. The nearest degree means the nearest whole number answer, right? Because the nearest degree would be like 43 degrees, and so that's a whole number. Okay, so what we're going to do here is we're just going to practice using the calculator at first. So if I know the cosine of A equals to that decimal, for example, 0.6547, I have the cosine as a decimal. I can use the inverse cosine of that answer, that decimal answer, and it will give me what A is in degrees, okay? And so let me just verify that my calculator is in fact in degrees still, okay? And it is, okay, you can see at the top that it is in degrees. Oh, hold on, my calculator is frozen. Here we go. Okay, so it's in degrees still. And then what I'm going to do is I'm going to use my inverse. So generally speaking, you usually have to click second. So second, and then this one was the inverse of cosine. Okay, and you'll see that you have that cosine minus 1. That's the inverse cosine or arc cosine. And then my decimal is 0.6547. 0.6547. Okay, and that's going to give me about 49.1, and so that's going to round to 49 degrees. So that means that a triangle with that cosine ratio is going to have a 49 degree reference angle. So this is 49 degrees, so that means that A is 49 degrees, okay? Do the same thing for this tangent C. So if the tangent of C is equal to the value of 2.4598, then that means that the inverse tangent is going of this value, okay, is going to equal to our reference angle C. So to find C, you just do the inverse tangent or the arctangent. Okay, so let's do that again. So we have arctangent of 0.6. Oh, this is written incorrectly. Let's fix this real quick. This should say 2.4598. 2.4598. So inverse tangent. And so second and then tangent of 2.4598. Was that? Let me double check if that's right. 4598. Yes. Oops. And that's going to equal to about 67.8. Since that 8 is a 5 or more, it rounds this up to a 68. So 68 degrees. So that's going to be about 68 degree angle, and that's what that reference angle would be. Okay, so C is equal to 68 degrees. Perfect. Okay, so now let's take a look at how to actually apply this. So it says, example 2, find the measure of the indicated angle to the nearest degree. Perfect. So whenever we want to use trig, first of all, we have to have a right triangle, right? And then we have to have a reference angle and then two sides that we can use when it comes to it being in a triangle, right? Which is what we do in geometry. So I can tell what my reference angle is because it's the angle I'm looking for. So this is going to be my reference angle. Instead of using a question mark, I would actually like to use theta. This is a Greek letter that we use very often for trig. So that is theta. So I would like to use theta instead of question mark just to get you used to it. So we're looking for theta, and in reference to that angle, we can label our hypotenuse, opposite, and adjacent sides, okay? So hypotenuse is across from the right angle, that's 41. The opposite to theta is going to be this blank side over here to the right, and then the adjacent side is going to be next to theta, that's going to be the 32 at the bottom. And so of the three sides, we only have 2 of them. So we don't know the opposite side. We can't use that one, but we can use the hypotenuse and the adjacent. So for SOHCAHTOA, for sine, cosine, and tangent. The one that uses A and H is going to be cosine. So it's going to be cosine of, we don't know it, right? And so we're going to use theta. So cosine of theta is equal to adjacent over hypotenuse. So 32 over 41. You can simplify. In this case, it doesn't simplify, but you don't even have to, because remember, we're looking for theta. So in order to find that theta, we have to use an inverse or an arc cosine. So we have to do cosine minus 1, the inverse cosine of this 32 over 41. We don't even have to divide it. We can just go ahead and type that into the calculator, either as division, so we can type this in as division, or we can use a fraction, right? We can use the fraction button. All right, so let's see what that would look like. So we're going to do the arc cosine or inverse cosine. So second and then cosine. And then what we're going to type in there is I'm going to go ahead and type it as division. So it was 32 divided by 41. Okay, and then I'll close my parentheses. Let me just double check. Is that right? Yeah. Okay. And then that's going to give me about 38.6, which rounds, I believe it says to the nearest degree. Yes, the nearest degree, it says right here. Okay, so we're going to round it to the nearest whole number. So that's going to be, the 6 is 5 or more, so it rounds up to 39. So that's going to be a 39 degree angle there. So that theta, that reference angle is 39 degrees. Okay. Next time I'll show you if you type it in as a fraction. Actually, I can show you here just so you can see it's the same answer. If we type that in as a fraction, we should get the same thing. So if we do inverse cosine again, but we type it in as a fraction, 32 over 41. And then the parentheses, there we go. Got to push it to the right. We get the same answer. Okay. Perfect. Okay. Let's take a look at another one. Now we have example 3. Find the measure of the indicated angle to the nearest degree. Again, we're going to use theta for our angle. So we're looking for this theta up here. That's our reference angle. Hypotenuse is, we don't know. There's nothing labeled there. Opposite side to theta is 11. Okay, it's again, the opposite side is always the one across from it. And then the adjacent side is going to be 13. So O and A are the two sides that we have. So that's going to be tangent. Okay, so the tangent of our theta angle is equal to O over A. So 11 over 13. And to find that theta, right, when you're looking for the angle, you do the inverse. So you do theta equals the inverse tangent, or the arc tangent, of 11 over 13. So I'm going to put that in my calculator. So the inverse tangent of 11 over 13 is 40.2. So this is about equal to 40.2, which as a nearest degree, whole number, is going to be 40 degrees. It's going to round down. So that angle is about 40 degrees. Okay, try the last one, and then we'll do it together. So try the last one, pause the video, try example 4, and then we'll do it together. Okay, so for example 4, I'm looking for theta. I'm going to call that angle at the bottom left theta. It looks like I have my hypotenuse of 78, I have the opposite side of 30, and I have the adjacent side of 72. So this may have tricked you a little bit because I actually have all 3 sides labeled. So you can use whatever trig ratio you want. As long as you do the correct ratio, right, with the correct sides in the correct order, you're going to be fine. So what I'm going to do is I'm going to go ahead and just ignore my adjacent side. I'm going to use my opposite and my hypotenuse. And so that's going to be the SOHCAHTOA, right, S-O-H, so sine. So my sine of my theta is going to be opposite of 30 over hypotenuse of 78. If you use something else, you should still get the right answer as long as you put the ratio correctly, okay? So now to find my theta, I'm going to do my inverse sine or arc sine of 30 over 78. And that's going to give me, so I'm going to put that in the calculator, second sine, and 30 divided by 78, and that gave me 22.6, which rounds, so that's about equal to 22.6, which is going to round up since the 6 is 5 or more, okay? So that theta is going to be about 23 degrees. If you used, for example, cosine, and you had 72 over 78, then you should get the exact same thing. It's the same angle, right? You're just using a different ratio. So no matter what, you should get 23 degrees for that one. All right, that's all I have for you guys. Thanks for watching. Have a great day.